Welcome to your next training video about quadratic equations. In this video, we're going to talk about the graphs of quadratic functions, which look like this. They look like parabolas. Parabolas always have a minimum point or a maximum point that is called the vertex. We'll talk about how to find that today. And just like any other graph, or like the linear functions that we've graphed before, they have intercepts where they touch an axis. Right? So just a reminder, if you're trying to find the y-intercept, you plug in 0 for x. We'll talk about that more in a minute. And if you're trying to find the x-intercepts, you're going to plug in 0 for y, just like you would do with other graphs. Okay? So let's talk about first intercepts. This might look familiar. It's from the last video about the quadratic formula. We've talked about the discriminant and how it tells you how many solutions your equation will have. Let's imagine we're trying to find the x-intercepts of this quadratic function. Right? If we plug in 0 for y, or for f of x, we plug in 0 there, that means we're finding the values for x, which, if we have a discriminant, that can tell us how many x-intercepts there are. We're trying to find the x-intercepts, that's why we put in 0 for y. So if we know that there is a negative discriminant and there's no real solution, that means also that there is no x-intercepts. So your parabola is going to look something like this, or even facing the other way, right? If your discriminant is greater than 0, if it's positive, that means you have 2 real solutions, which means you will have 2 x-intercepts. We'll go through 2 spots on the x-axis. If there is 1 real solution, if the discriminant equals 0, that means you will have 1 x-intercept. It will look something like this. And your x-intercept will be the vertex as well. Okay? So let's try finding the intercepts, and we're going to use the idea of a discriminant to tell us how many x-intercepts there are. Alright, so this question says, what are the intercepts? First, let's start with the y-intercept, then we'll move on to the x-intercepts. Oops. Y-intercept. That means that x equals 0. So I plug in 0 for x. Plus 4 times 0 plus 10. Alright, lovely. I love plugging in 0. That's just 10. So my y-intercept is going to be 0, 10. X-intercepts. Let's start with plugging in 0 for y, or for f of x, negative x squared, plus 4x plus 10. I'm going to start with the discriminant just to see how many solutions, how many x-intercepts, right, same thing, that I will have. So I'm just going to start with this part of the quadratic formula, which is the discriminant. B is 4, A is negative 1, and C is 10. So I'm going to have 16. Negative 4 times negative 1 is positive. 4 times 10 is 40. Okay, so it is positive. That means I'm going to have 2 x-intercepts. And I'm already on my way to find them, because if I plug in the quadratic formula, of course I could also try to factor this. It doesn't factor, but I could also use completing the square to solve it. Plugging in the quadratic formula, that's going to be negative 4 plus or minus the square root of the discriminant, which I already found. So I'm just going to go ahead and put 56 over 2 times negative 1. So I have negative 4 plus or minus 56 actually breaks down into 14 times 4. It's going to go ahead and bring out that 4, and it becomes a 2. Root 14 divided by 2. So negative 4 divided by negative 2 is going to be positive 2, plus or minus 2 divided by negative 2 is either going to be positive or negative, and so 1, and so I don't need to have another negative here because my plus or minus is already there. The square root of 14. Right? So my 2 x-intercepts, because I know I'm going to have 2 from the discriminant, are 2 plus the square root of 14, and 2 minus the square root of 14 with their accompanying zeros, right? If we put those in the calculator, just because it will help us graph them later, 2 minus the square root of 14 is negative 1.742, just rounding to the thousands place, and this one's going to be 5.742. So those will come back later. We're going to try to graph this once we can figure out the vertex. So let's talk about how to find a vertex. Right? We know on a graph, it's just the lowest point or the highest point. But if we're looking at an equation, there's a couple different ways we can look at it. There are different ways to write a vertex, to write a quadratic function. Okay, one is called vertex form. And here's why. It makes it very easy to find the vertex. When it is written like this, there's going to be a number outside of parentheses. It might be a 1, so it might not be there. And then inside, x minus some number h, all squared. Somebody completed the square, right, to get there. Plus some number k. The vertex is going to be the opposite of what's in here, so just h by itself, and then k here. If we look at this graph on the right, this equation written in vertex form is as x plus 2, right? Negative 2, negative 4 is my vertex. So opposite there is negative 2. Sorry, the opposite of negative 2 is plus 2. And then my k is negative 4, so it's been moved down 4. This form you'll learn a lot more if you are tutoring Math 110. This is called a transformation form. And so we have it written that way. If it's not written that way, it's probably written in standard form, which looks like this. It's got the x squared and just an x by itself, ax squared plus bx plus c. And there's some cool ways to find the vertex with this. You actually have the beginning part of the quadratic formula, negative b over 2a, and then whatever you get for that, that's your x value, so you plug it into f of x, and it will give you the y value for the vertex. So it'll be negative 2, negative 4. This same equation written in standard form is f of x equals x squared plus 4x. So we would take that negative b, be negative 4 over 2 times a, gives you negative 2 for the x value, the x coordinate of the vertex. And then we'd plug that in to the standard form, and it gives you negative 4, which is the y value of the vertex. So whichever way it's written, you should be able to find the vertex. Now, let's give it a try with that problem we just did. Okay, we already found the y-intercept. We already found the x-intercept. So let's now find the vertex, and then we'll make a little graph. Vertex, this is written in standard form, so I'm going to need my vertex formula for negative b over 2a. X equals negative 4 over 2 times negative 1. Negative 4 divided by negative 2. X equals 2. Alright, and then we plug that back in to find the y value. So we're going to find f of 2. Plugging in that positive 2. So 2 squared is 4 with the negative out front is negative 4. 4 times 2 is 8. Add those all together left to right and I get 14. So that means my vertex is the point 2, 14. So I could graph this. I plot the y-intercept, both x-intercepts, almost negative 2, almost positive 6. And then I can also have my vertex at the top of 2, 14. One other thing to remember about parabolas is that they are symmetrical. So if you know, for example, this point, here's our line of symmetry, the point 0, 10, I know from my vertex goes down 1, left 1 and down 2. I know that the one on the other side is going to do that as well. So wherever your vertex is, you can find more points by using symmetry. And that is graphing quadratic equations. And we've learned everything from this section. So we learned how to solve quadratics by factoring, completing the square, and using the formula, and we learned how to graph a parabola. Well done!